So our example is putting together the idea of instantaneous and comparing it to the secant line, which was the average rate from 2.1. Okay, so this question says, one more time, it goes average rate of change from last day 2.1 between 2 and 4. So that is between two values, right? So it's average rate. And then here is instantaneous rate at 2. So this one, this first one here, this is a secant. And this one here, this is the tangent. Okay, so that's a secant and the other one's a tangent. So what we have here is we have a comparison between the 2.1 lesson we did compared to the one that we just did here. Now, usually when we have instantaneous, I think that we would probably tell you which method we want you to use, whether we want you to use a preceding interval, a following, or a centered interval. I like the centered just because it always just feels like it's kind of merging the two together. If we don't tell you, you can choose, but I think probably we would tell you which method. Right? So for that instantaneous, we have using a preceding and getting closer, using a following and getting closer, or you have the centered, which averages the two, or the average of a preceding following, which means you do the two and then you average them and divide by 2. So look at that. And then we also have the new one, which I'll show you tomorrow, the next lesson, which is going to be the using the formula way. Right? So I'll tell you what that one's called when we get to it, and then you'll listen to the instructions. So this first one here for A, we have the average rate of change of the function between 2 and 4. So again, this is just going back to yesterday's 2.1 lesson and comparing the two. So we have m equals, and we're going to do f at 4 minus f at 2 all over, and it's 4 minus 2, right? So y2 minus y1 over x2 minus x1. We have to, going to lower that, make a bit of a space here because I got to do a fraction on a fraction. So we're going to do 3 over 5 minus 2 times 4 minus 3 over 5 minus 2 times 2. Right, so I just plugged in 4 here, 2 there, and on the bottom I have 2. Okay, and then we're going to calculate. I always center my equals like this so I know it's not off center. So see how I do equals in my line first. Then I go 3 over 5 minus 2 times 4, 5 minus 8, so can I skip that and just do -3? Is that okay? Okay, and then minus 3 minus 4, so just 1. We'll just skip that step. And then it's over 2. This becomes -1 minus 3 over 2. And that's -4 over 2. So my slope is -2, it looks like. Looks like my slope is -2. So the average slope between those 2 points is -2. That's it. I have no units, so you can just stop there. Okay, so it's good to stop there. So that's what we were doing yesterday. Secant lines, average between, that sort of thing. Then today what we're adding to it is instantaneous at 2. So again, we usually tell you which method we want because there's so many. So today I want to try, let's try on this one a centered interval. Okay, so using a centered interval. And we're just going to do m equals. And so it's around 2. So we're going to go f at 2.01 minus f at 1.99. There's one in the homework where you actually get 0 on the top, like when you plug it in, and it's because the slope is 0. So usually people are like, no, I got a 0, I'm wrong. Nope, the slope is actually 0. So one of your homework ones, in homework, you're actually going to get a 0, which makes sense because sometimes the slope will be 0. Does that make sense, right? If you have a parabola, what do you think the slope of a tangent line right at the very top or bottom is? 0, right? And you go, oh, that makes sense. So take a look at it. Okay, don't be freaked out when you see it. Be like, oh, it is 0 because it's the top or the bottom of my parabola, so it's okay. I know one of the homework ones you're like, it must be wrong. It's 0, but it actually is 0. Okay, so it does happen you get a 0 slope. Okay, this one, people usually ask how many decimal places because when I put it in, okay, so let's put this in. I'm going to do a little bit of a space. So we're going to go 3 over 5 minus 2 times 2.01 minus 3 over 5 minus 2, 1.99. And this is over 0.02. So now when I try to calculate this one, I go 3. If you want, you can do this all in one go, just because otherwise you're going to get a decimal and a decimal, but you can do this separately. So minus 2 times 2.01. Oh, it's not too bad. So that, but if you want, you can skip the middle step and go straight to the decimal. Okay, so if you don't want to show a middle step, you can skip this one. Do you want me to show it though, just in case? Right, I'll show it. Okay, I'm going to show it. But if you want to, you can skip to the next step. So some people skip this one and they don't do the bottom first. 5 minus 2 times 2.01 minus 3, and this is 5 minus 2 times 1.99 and 1.02. Okay, you don't have to show me this. You can go straight from, if you want, you can plug it right in, and then you can skip either to the next line or from here to the next line. And again, just because the numbers start to get such a pain in the neck to write down. So if you want to, you can. If you want to show the step, that's fine as well. Don't write too big. And then I get 3 divided 0.98. So when I get 3 divided by 0.98, see? It's this huge decimal, right? It doesn't terminate. So you do have to cut it off. I think 4 should be fine for everything that we're doing. So 3.0612, okay, minus, when I do this one, 3 divided by 1.02. Look, I got this non-terminating decimal again. So 2.9412, I rounded it. So I put the little dot above the line where I rounded it. You don't have to. Okay, but that's telling you that I rounded it off. So if you want, you can go straight from here, just telling me that I subbed in 2.01, and then I got 3.0612. Some people are like, I hate writing it. I'm actually worse. If I copy it, I'm going to make more mistakes. You know yourself, right? If you're like, no, I need to show a middle step, then show a middle step. And then keep more decimal places. So if I say 4 decimals, keep 5 throughout and then round it at the end, right? The more rounding you do, the more inaccurate it'll be. So keep more. So I'll say here, keep 4 decimal. And then keep more than 4 above, right? So if you have to round it twice, keep more and then round it to 4 at the end, right? So sometimes there's extra steps there, so always keep more than 4 and then keep it to 4 at the very last step where you're going to round it again. So keep 4 or more. I don't mind more. You don't have to go to 9. Don't go 9 decimal places and stuff, right? If you're like, oh, I kept a bit more, that's okay. Okay, so minimum would be 4. So 3.0612 minus 2.9412, and I got 0.12, 0.02. And I did not put an approximate sign here because I didn't round it again, so I just, that's the only step where I cut decimals off. And then when you divide it, it's 6, right? Isn't it exactly 6.02? It's exactly 6. Okay, and it's not always going to be 6. I accidentally chose two examples that are totally different, and all the slopes were 6, right? On the other page as well, right? Wasn't my other page 6? It's like, it's weird. I'm like, wow, I saw just, oh, yeah, 6. It's not always going to be 6, so it's not a fail-safe. Like, don't be like, hey, slopes are always 6. It's not true. Okay, this one accidentally became exactly the same slope. Okay, so if I ask for 4 decimal places, keep more throughout before, then round it to 4 and at the end. You can always keep 5 throughout until the very last step. At this point, you should be rounding at the end anyway. Yeah, but yeah.
For this question, wouldn't it be better to use like a bigger interval so you don't have to round?
No, smaller intervals is the whole point of it. Using bigger is like, so I understand your point, but then you're also getting more error. And the more intricate your graphs are, the worse it's becoming. So big is not better, definitely better, not better, okay? In the homework, they give you a chart, like an actual T-chart. The only interval they gave you is 0.5 off, so you have to use it. But whenever possible, you want the smallest interval possible. Because if you're going from like 7 to 8, yeah, that's not even a good one. So that's the whole idea of limits, that this gives you a better interval. Okay, and again, the more intricate your graphs get, the more important that getting a small interval is more important, because a slight bit off your graph, oosh, your whole slope's different. Because we're only doing like more simple graphs, bigger intervals don't matter, but as you get more intricate with it, it's going to get worse. So our hope is always to get the smallest interval possible. Yeah. Okay. Another question. Yep. Sorry. There's nothing left. I divided it. It was exactly 6. Yeah, yeah. So get as accurate possible. Like if it's 5.999, do 6. Usually it should hopefully round to something, right? If you need one decimal and you're like, oh, it's exactly 0.5, then do 2.5. Yeah, right? The slope could be a 0.5 or something. Yeah, just round it to whatever's reasonable. Yeah. Okay. Yep.
Why didn't you put an approximate equal sign at the end?
I didn't round it again. It became exactly. So I took my answer from above 0.12, divided by 0.02, and it was exactly 6. I didn't have to round it. So I put the approximate every time I physically took off the equal, like took off some decimal places. Here, I didn't take off anything.
Sorry,
yep.
But in this case, if there was more than 4 decimals, would it not equal 6 exactly?
Yeah, so it might be 5.99999, and then I would put approximately 6. Okay. Yeah, then I would round.
It's just for that last term you want 4.
Yeah, well, here, because if you round it to 3 and 3, you get 0. So then everything's 0, right? And I said, sometimes you will get 0, but that's after we took 4 decimal places, and it's because when you look at the question, you go, oh, it's the vertex. Of course it's 0. Here, if I round it to 1 decimal, I go 3 minus 3, I'm going to get 0. So if you round it too much or if you use too big of an interval, it's going to go wrong. So that's when you start to go too far off. So try to keep 4, which gets it more accurate, so you're not going to round too much. If you notice it's a 0, then double check and go, is it really 0 or did I round too much? Right? So if I go 1 more decimal and it doesn't, then it's not 0, yeah, right? So take a look to see if it's a rounding error or if actually it is 0. Yeah, yeah, okay? I know, it's always, and this is the problem is that people went, I feel like it's not accurate, I feel like it's not like precise. That's when calculus went, let's do a method, let's do a formula, right? This 0.0, how many decimal places, this is a frustrating discussion, right? Like, shouldn't I keep infinite number? And that's what the formula does, is that the formula doesn't round to anything, it keeps it as algebra. Right, so there's no rounding. So that's where calculus comes. It'd be beautiful. We don't have to do any of this awful rounding anymore.